Welcome to the lecture on Numpy. In this lecture, we are going to look at what number library is about and what we'll be seeing how we can use the number library to do some numerical operations on it so that it will come in handy in our upcoming lectures. So here we are going to introduce you to the Numpy library. Basically, Numpy is a Python package and it stands for numerical Python. Also, it is a fundamental package for numerical computations in Python. So if you want to perform any numerical operations, that NumPy library will be used, and it supports n-dimensional array objects that can be used for like processing multi-dimensional data, and it supports different data types. So in previous lectures, we already seen about Python arrays. So for just recall purpose, an array is just a data structure that stores values of same data type. So if you are creating an array, then all the elements in the array should be of same data type. So we have also seen another container called list, which can contain values corresponding to the different data types. But arrays in Python can only contain values corresponding to the same data. So we have already been introduced to like what Python arrays are. So in this lecture, we are going to discuss about the advantages of using NumPy array. So NumPy array is a grid of values, all of the same data type, and is indexed by a subtuple of non-negative integers. NumPy is one of the core libraries for scientific computing in Python, and also provides a high performance multi-dimensional array object, and using NumPy mathematical and logical operations on arrays can be performed. So you can say that is why we prefer using the NumPy arrays over built-in arrays in the Python. So in the Python, the number of dimensions of the array is called as the rank of the array, and a tuple of integers giving the size of array along each dimension is known as shape of the array. So once you have an array with you, if you want to look at the shape of it, and then it is going to give you a tuple of integers giving the size of the array along with each dimension. As we know that NumPy provides a high performance multi-dimensional array object, so elements in NumPy arrays are accessed using the square brackets like the other arrays, and it can be initialized by using the nested Python list. So now let's see some practical aspects of NumPy, that how we install NumPy in Anaconda Jupyter Notebook, then how to use NumPy, and the various things that we have discussed, that is rank and shape. So let's do some practical about NumPy. So there are several ways to create arrays. For example, you can create an array from a regular Python list or tuple using the array function. So here I am creating a list which contains the values ranging from 1 to 6, and the name of the list is my list, and you can see the output that the values are enclosed inside the square brackets. So to create a NumPy array, we first need to simply import the NumPy package, and also to import we need to first install the NumPy library on our machine. So for that we need to run a command, that is pip install NumPy. Just remember one thing, when you run this command, that is pip install NumPy, after that you need to restart the kernel. When you click on it, when you run this command, you will get a message that requirement already satisfied and you may need to restart the kernel. So for restarting the kernel, you just go here and restart the kernel. So restart, so that it will work properly. So now after like installing Numpy, what you need to do, this is the first command. So this is giving this output. Then no, you need to install the Numpy. For installing Numpy, you just need to write pip install Numpy and run this command. It will take some time to install Numpy. Then it will display some messages regarding the Numpy. So see now it is installed. So you need to restart the kernel to use the updated packages. So after that, now that I have installed the Numpy on my machine, so you need to create Numpy array, and for creation of Numpy array, we first need to import the Numpy package. So for that, I need to use import command, that is import Numpy, and here I have imported it as np, and I am just using np dot array, and here you can see np dot array is used, and the basic n dimensional array is created using an array function in Numpy. So here I am using the array function from Numpy library, and every Numpy array is a grid of elements of the same type. So you can see here. Numpy provides a large set of numeric data types that you can use to construct arrays. So you can say Numpy tries to get a data type when you create an array, but the function construct erased usually also include an optional argument for to explicitly specify the data type. So if you can see here, the first argument to the array function is my list, which has a list of values from 1 to 6, and the next argument is d type, which is equal to integers, which specify that I am going to create an array with the data type integer. And suppose if you are not providing anything, so it will automatically guess a data type, and when you create an array itself. But if you want to explicitly specify the type, then you need to do this, like d type and the type of the values. So here I am creating an array using the array function from Numpy, and I'm just printing it. So just you can see array is created here with the help of the array function. So now after printing this, what I'm going to do here, I am printing the type of array. So this basically gives you to the data type of the object, and if you printed the output is class Numpy dot and array, because Numpy's main object is the homogeneous multi-dimensional array, and it will give you the type of array dot and array irrespective of the dimensions of your array. So the next thing is to learn about the length of array. So for that we have used a function, that is len, which is going to give you the total number of elements present in the array. So here you can see total number of elements in array is 6, and you can also get the number of x's of the array by giving the ndim command for ndim property, which is basically stands for number of dimensions of the array, and it says 1 because you have only one dimension to it, that it means that you have only one access to your array. So now let me just check dimension of the array. So for that array, checking the dimension of array is going to give you an output of tuple of integers, including the size of array in each dimension. We know the dimension of array here is 1, and let us just check the size along with each dimension. So you can see automatically you will have a vector when you create an array. So you will have 6 rows with 1 column, that is where you have 6 and nothing. And about the shape, that is shape of an array can be changed with various commands. So here I am going to use a shape or a reshape function that is going to be used to reshape your array, but you know that following command will return only your modified array, and but it is not going to change the original array as well. So let us see that how to reshape the array or how to use reshape function. So here you can see 3 comma 2 is represents, it is going to reshape the column with 3 rows and with 2 columns. So I have reshaped the array which has 3 rows and 2 columns. So now after reshaping it, if you check the size of array, it is going to give you the output as 3 comma 2. So we have reshaped the array as for the dimension 3 comma 2. So but if a dimension is given as -1 in a reshaping operation, like the example that I have given, then the other dimensions are automatically recalculated. So because the 3, that is, you can see here the 3, the first argument 3 represents that how many number of it should have the, and the -1 represents the other dimension is going to be calculated automatically by the Numpy library, because this is basically just an example that is to illustrate that how the arrays are created and how we can perform some operations on arrays. So but if you are if you are dealing with large set of arrays, then in that case you are not sure about the dimensions of your array. So then if you just want to reshape it, so according to your desired dimension, then you can just use -1 as any of the dimension. So because in order to use reshape, at least you should be specifying by specifying one dimension exactly, and the other dimension can be calculated automatically by using the Numpy array. So here I have fixed -1 along the column dimension. So you will have 3 rows and 2 columns, and this has been calculated according to the size of your array. So you can say basically it depends on the number of elements that array consists of. So since I have 6 values, I have just given it as 3. So now let's see that how to initialize Numpy arrays from nested Python list. So now you can see here, initially we had only one list as an argument to the number array, but here I'm going to create an entire array from the nested Python list, and for that I have created 3 sets of lists having few numbers to it. So I have 3 lists. The list name is my list 2, 3 and 4, and I'm using the array function from Numpy library, and inside that I am going to give list of list as the elements that needs to be passed in as an argument. So if you can see here, my list itself is a list, and I have given 3 lists and then given the square brackets outside of it, and inside the list also I have 3 lists. So if you just print it, it is going to give you the output like in this way. So you have created an array called mul underscore arr, which has some values to it. So if you check the shape of it, so for that I have written here like mul underscore arr dot shape. So it gives you 3 comma 5, that means 3 rows with 5 columns, and you should be able to reshape your multi-dimensional array as well using the reshape function. And here I am just reshaping the multi-dimensional array as 1 comma 15, so that I can have the array values in a single row with 15 separate columns. So you can see the output like this way. So now we are going to discuss some NumPy attributes that you can fetch from your NumPy. So here you can see I have just created a array called A, which has two lists to it. So it has 2 rows and 3 columns. That is the shape of array. Is The shape is one of the attribute. As I have already told you that there are several ways or several commands that can be used to reshape the array. But here I have given you an example on that how to reshape the array using the reshape function. So another method which you can use to reshape the n-dimensional array is can be a dot shape, which basically gives you the dimension of array, and I am just passing a tuple which contains some integers which also describes the dimension of array as the input. So here you can see I have reshaped an array with the dimension 3, 2. So you can see the reshaped array is shown here, and I am also mentioned that how to reshape the array using the reshape function using this command. So here I am using a shape function, whereas here I am using the reshape function. So for resizing the array. So you can see outputs are same for both functions. So now you can see if you can say you will also be able to create a sequence of values and then created as an array using the range function. So I have given a range of 24. So it is going to give me a sequence of values starting from 0 to 24. So, but the downside to use the range function is you would not be able to see what are the values that are there under the created range. It is just going to return the range of values like 0 to 24 as an output when you try to print the R. So the range function is often used when you are dealing with control structures, and if you want to iterate a value with a given sequence of values, using range, in that case range will be very helpful. But to create a sequence of values, we can use a function called arrange from the NumPy library. So here you can see an array of evenly spaced numbers. For that I have used arrange. So it is called as a range because from NumPy it is going to create an array based on the sequence of values that you have given as an input, but it is going to return an array. That is why the function name itself is a range. So the arrange function syntax, the start value, stop value, and then the incremental value. So it is basically takes in 3 arguments. I have just given only one argument. You can see here. So by default, it is going to take that value as a stop value, and if you are not given any start value, it is going to start from 0. And by default, it is going to increment the value, but number 1, I have given 24 here, but you would have got till 23. That describes that stock value, whatever I have given here, it will return 1 minus the value, that is 23. So here I am providing 24, but it is giving 23. So if you check the dimension by using the ndim command, ndim property, then you are having the value 1 here. Now next we are having, suppose if you can see here, this is the original array and I am just wrapping the array as a given 6 as the first argument. It is going to keep all the values into 6 vectors, and each vector will have the size 4. One under each vector you will have values in 4 rows, and with single column from 0 to 3 is a vector, and also it has a dimension 4 cross 1, and the second vector also has 4 values to it in a single column. So similarly in other vectors you can see here. So you can see I have given the first dimension as number of vectors it should have, or under each vector what is the size, that is 4. One that represents the number of rows and the number of columns that you are going to use to reshape the array. So this is how we can reshape the array using the reshape function. So now let's perform some arithmetic operations on Numpy arrays. So I have created two arrays here, and the elements inside the x and y arrays are of float 64, and you can perform some of the arithmetic operations like addition, subtraction, multiplication and division. So let us take an example. So using these values, when you print these values, you will get these values as. So now there are two methods for adding these two arrays. The first is you can directly write just print x plus y, and the second method is just you need to provide parameters within the add function. So you can write np.add, and in brackets you have to write x comma y, and the results for both will be same. Same way you can perform subtraction. For that you need to write x minus y, otherwise you need to write the function name, that is subtract. Similarly you can perform multiplication by the multiply sign, that is asterisk, or you can write the multiply and x comma y. So simply you can get the values. So now if you want to get the dot product of two arrays, then you can use the function called dot x. Dot of y is going to give you the dot product of two arrays x and y, and you can use the dot function either by applying it on one array or then using it on the other array, or you can just use np dot dot, and inside the function you can just give the two desired arrays that needs to be multiplied, that values to be multiplied. And similarly you can perform the divide operation between two arrays, that is x and y, by using the slash operator or by using the divide function. So here from the Numpy libraries, so all of the addition, subtraction, multiplication and division using the required commands is going to do the element wise operation between two arrays. So in last you can see these three commands that I have tried, which basically first used to compute sum of all the elements. Second is it will compute all the sum of each column, and the last one is sum of each row. It will show you. So hello all. So now we are going to start about learning Pandas library. So in this lecture we are going to see about the Pandas library. Specifically we are going to look at the following topics. That first we get introduced to the Pandas library. After we are going to see that how to import the data into Spider or Jupyter Notebook. We will be looking at how to create a copy or create a copy of the original data with the two methods. And we will also be looking at how to get the attributes of data. Followed by that we will see or how to do indexing and selecting data. So now first of all, introduction to Pandas. So to introduce you to the Pandas library, it provides high performance, easy to use data structures and analysis tools for Python programming language. It is an open source Python library which provides high performance data manipulation and analysis tool using its powerful data structures. And it is also considered one of the powerful data structures when compared with other data structures because of its performance and data manipulation techniques. It is available in Pandas. And as the name Pandas is derived from the word panel data, which is an econometrics terms for like multidimensional data. So here you can see here is the description of about the data frames. So you can see data frames consist of two dimensions. The first dimension is the row and the second dimension is the column. That is what we mean by the two-dimensional and size mutable. Whenever we say data frame, so data frame is a collection of data in a tabular fashion, and the data will be arranged in rows and columns. So where we say each row represent a sample or a record, and each column represent a variable. So the variable in the sense the properties that are associated with each sample. Second point is that potentially heterogeneous tabular data structure with labeled axes. So here heterogeneous tabular data structure in the sense whenever we read a data in Spider or Jupyter notebook, it becomes a data frame and each and every variable gets a data type associated with that when you ever read it. Also, we do not need to explicitly specify the data type to each and every variable, and that is basically based on the data or the type of data that is contained in each variable or a column. And we mean like labeled axes, each and every row and columns will be labeled. Row labeling the index for each rows, which is starting from like 0 to n-1, and the labels for column in the sense the names for each variables, those are called labeled axes. So whenever we say labeled axes, the row labels are nothing but the row index and the column labels are nothing but the column names. And this is about the basic description of the data frames. Now we have already seen that how to import the data in Jupyter notebook. So same steps are for Spider also. So for that we are first importing the libraries that are import OS. So we need to import this. Whenever you import any library, we use the command import. And here OS is the library that is used to change the working directory. So once you open your Jupyter notebook, the default working directory will be wherever you have installed your Python. And we import OS to basically change the working directory so that you will be able to access the data from your directory. So also next we have import pandas as PD. So before using this command, you need to first install the pandas on your Jupyter notebook. And same way, if you want to import Numpy, you need to install Numpy on your Jupyter notebook. Then by creating this you can say for pandas library, I'm using a PD, and for Numpy, I'm using a variable that is np, that is for Numpy. And for changing the working directory, we have already used that os.chdir for change directory. And here I'm changing from D in the folder pandas. We have seen all these steps already. So here you can see importing the file. Now this time I'm using a different data set, that is toyota.csv, and also by index call 0, first column becomes the index column. So I have used this particular command also here. So now next new thing that we are going to learn is that creating copy of original data. So how to do this? So first of all, let's see that we are having, you can say, first of all, let's understand why we need or how to create the copy of original data, because You can say there might be cases where we need to work with the copy of data without doing any modifications to the original data. So let us see in detail that how to create a copy of original data. So in Python, you can see we have two methods. One is the shallow copy and the second one is deep copy. So first, let us look at the shallow copy. The function row represents how to use a function and the description represents what does that function means. So you can see in shallow copy, you can use the dot copy function that can be accessed. Here you can see that can be accessed whenever you have a data frame. So since I have cars underscore data as data frame, so I can use dot copy. And if you want to do a shallow copy, for that you can use deep equal to false. By default the value will be true. So there are two ways to do a shallow copy. One is by using the dot copy function and another is by just assigning the same data frame into a new object. So here you can see I have assigned cars underscore data as an ampersand using the assignment operator. You can see here. So this also means that you are doing a shallow copy. So shallow copy means, in the sense, basically if you are doing a shallow copy, it only creates a new variable and shares the reference of the original object. So you can say it does not create a new object at all. And also any changes made to a copy of object, it will reflected in the original object as well. So whenever you want to work with the mutable object, then you can do a shallow copy where all the changes like that you are making into SEMP, this particular variable, will be reflected in your cars underscore data also. So now let's see about deep copy. Here you can see the deep copy content. So we use the same command dot copy, but we set the deep as true, and by default the deep value will be true. So whenever you use dot copy, you are doing a deep copy, and as you see that I am doing a deep copy, and by creating a new object called cars underscore data 1, where this particular object like cars underscore data 1 is the copy of original data, that is car underscore data. We'll show you the practical part of this is also. So now you can see what deep copy represents. See, a copy of object is copied in another object, like the copy of cars underscore data is being copied in another object called cars underscore data with the like no reference to the original data. And also whatever changes you are making it to the copy of object, that will not be reflected in the original object at all. Whatever modifications you are doing in cars underscore data 1, that will not be reflected in that data frames a lot, and the original data frame will not get affected by your modifications. So there are two cases. You can choose any of the copies according to your requirements. So whenever you want to do any modifications and reflect back to the original data, in that case we can use shallow copy. Whereas if you want to keep the original data untouched and whatever changes you are make, that should be reflected in the copy alone, then in that case you can use a deep copy. Now here you can see that how to create copy of the original data. We have discussed two methods are there, the shallow copy and the deep copy. So here I am just doing a deep copy by creating the new object called cars underscore data 1 of the copy, that is cars underscore data, which is the original file, with the help of dot copy function, and make this option true. So you can create copy of original data through deep copy method. So now we will see that how to get attributes of data. Attributes in the sense like getting the basic information out of data. So one of it is called getting the index from the data frame. So the syntax For that, here you can see data frame dot index. Dot index can be used whenever you have a data frame. So to get the index, index means like row labels. So whenever you want to get the row labels of the data frame, you can use data frame dot index. So here, as I am using the copy created by the method, that is deep copy method, I am using or performing these attributes properties on that. So for that I have written that cars underscore data 1, and I'm using dot index function that will be give me the output for the real row labels of the data frame. So if you see, the row labels is ranging from 0 to 1435, where the length is 1436. So the indexing in Python starts from 0 to n minus 1. So this is how we get row labels from the data frames. Now second, we are having next, that is data frame dot columns. So about like how to get column names of the data frame, we will use this. So you can get the column labels of data frame using dot columns. So by writing cars underscore data 1 dot columns will give you all the column names of your data frames. The output is just an object which is a list of all the column names from the data frames that is we are using, that is car underscore data 1. So by running this command, you can see by getting the attributes of the data like row labels and column labels, you will be able to know from which range your row labels are starting from and what are the column names that you have in your data frame. Now next is we can also get the size, that is like we can also get the total number of elements from the data frame using the command size. So by using dot size, we can use this command. So here you can see this is just the multiplication of 1436 into 10, where 1436 are rows and there are 10 columns are there. So when you multiply, then we will get the total number of elements, that is what the output represents. So you can also get the shape or dimensions of the data frame using the command dot shape. So just running by this. So here you can see data underscore cars underscore data 1 dot shape will give you how many rows are there and how many columns are there. So the first value represents rows and the second value represents the number of columns. So next we are having another attribute, that is data frame dot memory usage. So this will tell you that memory usage of each column in bytes. So to get the memory usage of each column in bytes, you need to write the command name, the data frame name dot memory underscore usage, and this will give you the memory used by each column in terms of bytes. So when you run this, you can see it is showing you the variables and the memory in terms of bytes. All the variables has used the same memory, and the data type that you are seeing here is the data type of output, that is D type. Now next we are having another, that is how to get number of x's for array dimension. So to check that how many x's are there, we can use dot endim function. So by running this, you can see only 2 dimensions are there. So one dimension being rows and the other dimension being columns. So all the rows forms one dimension and all the columns forms the other dimension. And just because we have multiple variables, it does not mean that we have multi-dimension to your data. The data frame consists of 2 dimensions. It becomes a 2-dimensional data frame. And if you see a 2-dimensional array, that stores a data in a format that consists of rows and columns. So that is why our data frames dimension is 2. So next we will see how to do indexing and selecting the data. The Python slicing operator, that is this one, which is also known as the square braces, and the attribute called dot operator, which is being represented as a period, that are used for indexing. And indexing basically provides quick and easy access to pandas data structure. So whenever you want to index or select any particular data from your data frame, the quick and very easy way to do that will be using the slicing operator and a dot operator. So now we will see how to index and select the data. So first thing that we are going to see is about the head function. Here I'm using the head function. So basically head function returns first n rows from the data frame. So syntax is basically data frame, that is the cars data1 dot head. Inside the function you can give how many number of rows it should return, and I have used 6 here. That means that the head function will return me 7 rows. But if you note, by default the head function returns it will only return only the first 5 rows from your data frame. So you can also specify your desired value inside the head function, and if you do not give any value, so by default it will give you the first 5 rows. So if you see, it returns 6 rows with all the column values. So this is very useful whenever you want to get the schema of your data frame. So to check what are all the variables that are available in your data frame, and what basically each variable value consists of. So for that, or you can say in that case, the quick method or the quick way to do is using the head function. So another, we are having the tail function. So when you want to get the last few rows from your data frame, so you can do that by using the tail function. So tail returns the last n rows from the data frame that you have specified. So I have used car underscore data 1 dot tail. When you run it, so you are getting 5 rows from your data frame, and this will be a quickest way to verify your data whenever you are doing sorting or appending rows. So now we have seen that how to access the first few rows and last few rows from the data frame. So there is also another method, or a method to access a scalar value. So the fastest way is to use the at and iat method. So basically the at provides label based scalar lookups. Whenever you want to access a scalar value, you can either use at function or use iat functions. If you are using at function, here you can see, basically need to give the labels inside the function. That is what it means as label based scalar lookups. So I am accessing a function called dot at, and inside the function the value should be your row label and the second value should be your column label. And I am accessing the scalar value which corresponds to the 5th row and corresponds to the fuel type column. So whatever I have given here is just the labels for rows and columns, and the value corresponds to the 5th row, and the fuel type is diesel. So this is how you can access a scalar value using the add function. And another method is iAdd function. So here you can see I have used dot iAdd function, where 5 is the 6th row and 6 is the 7th column. So value corresponding is 0. So through this method also you can access the scalar values using the row index and the column index. Now next we are having how to access a scalar value from your data frame. So there is another option. So you can access a group of rows and columns by labels. That can be done using this LOC operator. So we will see how to use this operator to fetch few rows or columns from your data frames. So whenever you are using the L.loc operator, you should be using a slicing operator followed by the function. And inside the function, you just basically need to give two values. One should represent the row labels and the other should represent the column labels. So here I want to fetch all the row values from a column called fuel type. In that case, I can use colon to represent all. You can see here. So you will getting all the rows which are under the fuel type column, and you can also give multiple columns here. So if you can give like for example fuel type and price is as a list. So basically when we say list, you can just give the values inside the square brackets. So in that case you will get all the row values based on the multiple columns. So in this lecture we are going to see that how to create basic plots using the Seaborn library, and the basic plots include scatter plot, histogram, bar plot, box and whiskers plot, and pairwise plots. So let's see each one by one. But before seeing these plots, let us first understand that what is Seaborn library. So Seaborn library is a Python data visualization library which was built on top of matplotlib library that provides a high level interface for drawing interactive or informative attractive statistical graphs. So using Seaborn library, we are going to first see that how to create this scatter plot. So for that I have just include all the libraries, Pandas, Numpy, matplotlib, and the new one, that is Seaborn. So we need to first install or import these libraries. After importing these libraries, we will going to work with Seaborn and can draw multiple graphs from these. So here you can see I have imported libraries into Spider or Jupyter notebook, and after that just import the data that will be used for visualization. So we are going to import the toyota.csv file, and I have used pd.readcsv for that. So after that I am getting, can see that 1436 observations and 10 columns are there. So we are now familiar with this data set, that is Toyota, and they are just the details of cars. So basically our main objective is to understand the data pictorially or visually. So we need to consider only the rows whenever the records are filled, because we would not be able to interpret anything from the question mark or from filled, because we would not be like cannot understand the nan values, nan. So now let's see that how to remove missing values. We have already seen this thing, that how to remove the missing values from the data. So for that I have used this. You can see here after removing the values, the data set having 1096 and 10 values is there. So only 1096 observations with 10 columns are there. Now next we are having how to create the scatter plot. So here we are going to use plot of price versus age, and that will be built using the default arguments. So if you see the first line, I have given as sns.set. That means that we are giving a theme to the background of plot, and theme was being dark grid. That means that you will have a dark shade as a background. of your plot, and you will as well as have a grid also. So you can basically set themes to your background, and dark grid is a preset Seaborn theme. You can as well as set themes that are available from the Seaborn packages. So now you can see that reg plot stands for regression plot, and inside the function you have to specify the variable for x-axis and y-axis. Because it is going to be the scatter plot of price versus age, we need to give age under the x-axis and price under the y-axis. So we can check how price varies with respect to the age of cars. Here you can see that I have accessed the age variable from the data frame cars underscore data. Similarly, I have accessed the price variable from the cars underscore data. So here you can see this would be output that you will be getting by setting the style as dark and giving x as age and y as price. So this is through the default arguments. Now if you see this, here you can see that we are going to do a scatter plot of price versus age without the regression fit line. That is very easy. You can retain the same command as we are using in the previous slide, but you just need to add another parameter called fit track, and you can just set them to false. So you can you can see here that as mentioned earlier, by default it is true. That is where you got a regression line over those scattered points, but if you said they are as false, you would not be getting the regression line. Here you are getting the regression line over the graph, but here you are not getting this. So we have not specified any labels to x-axis and y-axis. It is already being shown here. That is how, because it takes the label from variable name that we have already given here. You can see the values 0, 10, 20, 30 are the values from the variable age, and from plotting context these are called x-tick labels, and 5,000, 10,000 values are y-tick labels, that is on the y-axis, that are also called grids, and the points, the scatter points, are called markers. So we have a solid round points. Now next you can see here scatter plot of price versus age by customizing the appearance of markers. So just I have changed the appearance of markers by giving this point, that marker equal to star. So you can see the, here you can see the marker appearance of markers as stars. Next we are having, here you can see that create a scatter plot of price versus age by fuel type. So by fuel type, in the sense we are going to add one more variable into the scatter plot, that is the variable fuel type. So why we are going to add that? Because it is of interest to check the relationship between price and, or you can say price with age by adding another variable fuel type, like how price varies when the age increases with respect to different fuel types of the car. So that can be added by using the parameter called HUE, and including another variable to show the fuel type categories with different colors. So here you can see that add fuel type under the argument called hue, and we are going to represent the fuel type with respect to different colors. So you can see that by using the LM plot, that is from the Seaborn library, and this function which combines regression plot and phase, it is very useful whenever you want to plot a scatter plot by doing conditional subsets of data. or by including another variable into the picture. So in that case, LM plot will be very useful. Now you can see what is the output that we are getting. See, you can see price versus age by fuel type. It is the same scatter plot, but where here you can see we have just differentiated the data points using the categories that are available under fuel type, but we have just differentiated the data points based on the fuel type categories. So red represent the diesel, blue represent the petrol, and the green represents the CNG. So if you see here, there are more data points or there are more cars that are of petrol fuel type, and price is really higher for the cars which has diesel fuel type, and the price is comparatively lower for the cars which have CNG fuel type. You can also check the relationship between price and age, as we know that whenever the car's age is high, the price is very low, and whenever car's age is low, the price will be high. Similarly, you may also custom the appearance of the markers using transparency, shape and size, and how we differentiated the points using colors here, different levels of transparency to the points to represent the categories. You can also do the same thing by giving different shapes and by giving different sizes for that points. Next, we are going to look at a plot called histogram. We are going to plot a histogram with default kernel density estimate, because using the Seaborn library, by default it gives you a histogram with the kernel density estimation. So the command that need to be used this is this TIST plot, that is the representative of distribution plot. So that is from the Seaborn library of used, that is ns.displot, and input should be any numerical variable for any continuous variable, because histogram can be plotted to check the frequency distribution of any continuous variable. So in that case, age is one of the continuous variable. So from that data frame, here we are interested in looking at the frequency distribution of age and how the values are distributed under the age variable. So in that case, you can use or you can access the age variable from data frame cars underscore data. So this is being the representative of x-axis, and as you know, by default it gives you the kernel density estimation. So it gives you work curve over the bars, which is the representation of distribution of variable, that is age, and on the y-axis you have the kernel density estimate. So, but if your interest is to get the frequency distribution in terms of the counts or numbers, then you can also get rid of kernel density estimate and then have the count on your y-axis. So for that, you can see we are going to plot histogram without the kernel density estimate here. So for that, what I have done is I have just, you can do that by setting KDE is equal to false. So if you give that, the output will be similar to this. On the y-axis, it is just representation of frequencies, or the count on x-axis. You have the range of values from age variable. So you can see here. And you have too many intervals here, so it is very difficult to interpret from this plot. The range is about 75 to 80, where the car's age is more than 6 years. The count is really high, and there are very few cars which are new. That is what we can interpret, because there are two extreme here. One is really high and the other is really low. So in that case, you can also have a control on how many number of bins you want to have on the plot, so that by having the control on bins, you will be able to quickly interpret from the distribution of your age variable. So let's see that how to fix So for that I need to use this command. You can see. So here you can see retain the same code as in the previous one, but you can just add bins as equal to 5, so that you will have only 5 bins in your histogram. Bins are nothing but the range of intervals or range of the intervals. So from this plot, by having the number of bins as 5, it is very clear that the frequency is really high for the bin value 70 to 80, and wherever the car's age is above 5 years, the frequency is high. And because most of the car's detail is about the cars whose age is about 70 to 80 months. So, but you have only very few cars which are very new in our data frame. That is why the frequency is very low in the range 0 to 50.